Hi, our next speakers are Tim and Rika, and they're going to be talking about living with technical debt, as I'm sure you can see from the screen, and they'll be happy to have questions later if there's any time.
Amazing. Morning, everyone. Thanks for joining us for our talk on living with technical debt. Today, we're going to be talking about how you can acknowledge it, specify it, and ultimately then try and reduce your technical debt. So to start this off, I actually want to ask a question, which is, what is technical debt? And when I ask this to people, I usually start to hear answers like it's frustrations you feel within your team, it's people starting to complain about pieces of their code base, it's issues where development's getting slowed down, things are taking longer than they should, and again, that leads back into more and more of that frustration. It's then questions around confusing code. It's that piece of the code base that no one really understands what's going on in there, or where anyone new who joins the team, they look at it and they're just like, why did someone write it this way? It's those types of problems where every time you're working on a specific piece of the code base, bugs are just building up and building up and building up. Or my personal favorite, it's just having that piece of the code base that really nobody wants to touch. And we've all, I think, been in that situation where we're working on a team that has that piece of code. Oops.
So in order to facilitate better conversations about technical debt, we actually asked folks and created a survey. And this was one of the questions we asked, that is there a part of your code base so complex no one wants to touch it? And 2/3 of the respondents said that yes, this scary piece of code exists indeed. And fortunately, some of them were also kind enough to give some details about how this piece of code looks like and what makes it so scary. So some of them gave rather vivid descriptions, others were more concise about it.
And then others were maybe scarily concise about it, which is they have a line where nobody knows what it does, nobody knows why it's there, but if you take it away, everything breaks. And just taking a step back real quick, though, who are we? Why are we talking about this today? So Rika and I are both from Sorcery. I'm Tim.
And I'm Rika. I work as a software engineer on the code quality tools of Sorcery.
And so at Sorcery, as Rika mentioned, we're building code quality tools that are very focused on helping people improve their code, make it more Pythonic. And so we think about this issue of tech debt and of code quality a lot. But I want to revisit this elephant in the room of what is technical debt, because when I asked that question and kind of gave some of those ideas for those answers I often hear earlier, I wasn't really actually saying what technical debt is. I was more describing symptoms that people feel, which is a really important piece of it, because technical debt is kind of this fundamentally intangible thing. It's something where we notice the symptoms, we recognize these issues, but we don't always know what it is. And so I think it helps to go back to 1992 when Ward Cunningham first kind of gave this description of technical debt as this metaphor for financial debt. And it's this idea that every time we're shipping code, especially when we're shipping code for the first time, we're basically going into a level of debt because we're taking shortcuts to get that code out there. And those are good shortcuts to take. It's important to not be kind of making sure our code is absolutely perfect every single time, but we just need to recognize what are those trade-offs that we're then making into the future. And just like financial debt, we're going to actually have to pay back interest on that technical debt over time. And with technical debt, that interest is that long-term slowdown that we go into. But then we also have this notion of the principle of the technical debt, which is those actual design decisions we made in the first place that at some point in the future we're going to have to fix.
So in our survey, besides asking people about scary places in their code base, we were also asking them about how they spend their time. And this actually shows that this technical debt metaphor is quite fitting, because this kind of problems do create some real costs. So we saw some significant correlation between the level of technical debt and how much time people spend trying to figure out what this code is actually doing, which is probably not surprising. And also there was a significant correlation between how much time they spend fixing bugs, which might have two different causes or two different things play into this, that there are more bugs. And if they occur, it's much less clear why they occur and what's going on. So it takes more time to fix them. And on the other side, unfortunately, they can spend less time writing new features. And this so the chart what you see is from our survey, but there have been other surveys echoing quite similar results, for example, from CodeScene, or one big survey which was behind the DevOps report, that the time spent with unplanned work varies between 10 and 80%, and where a specific team falls in this quite big range, that depends highly on code quality.
Yeah, and just to bring it back to the kind of financial metaphor here, I think this paints a nice picture of what is that interest you're actually paying on your technical debt. That kind of delta between those medium and high tech debt teams and the low tech debt teams on the kind of fixing bugs and the figuring out how your code base works and the lack of time you can spend on actually building new features, that gap is that interest you're continually paying on that slowdown. One of the other things we looked at is, do teams actually measure their technical debt in any way? And the vast majority of teams tell us they don't, which makes sense, and we'll get into this in a minute. Technical debt, as I said, it's kind of an abstract concept. It can be hard to be made concrete, and it can be hard to then measure it. But at the same time, we ask teams when they're estimating their work, do they actually take into account where in their code base they're working? And the vast majority of teams do. So even if you're not explicitly measuring your technical debt, we probably all have some level of an innate sense of where has it built up over time in our code base and how is it affecting us in the day-to-day.
So again, our survey wasn't the first one to point out this contradiction, that this thing exists and we try to take this into account but don't have really good tools to manage it. And one great resource we can recommend is the book Managing Technical Debt from the year 2019. They provide various steps how to try to tackle these rather hairy issues. And the very first one they say is to make it concrete. And one thing they emphasize with this making it concrete or more specific is that whenever there starts to be a discussion around technical debt, topics which are more like organizational, historical issues often come up and got mixed in. And their recommendation is that, yes, try to fix the root causes, but focus on the real technical problem.
Yeah, and so when we think about technical debt and managing it, we kind of think about it as going through a three-stage life cycle for an individual piece of debt. So the first stage is this intangible stage, and we'll get into more detail here of really what this means. But this is the point where you start to feel those symptoms that we talked about at the beginning. You start to feel those slowdowns, but you can't necessarily put your finger on what is actually causing that technical debt. The second piece is you've found that specific problem. You can articulate, here is exactly what's causing us to have that technical debt, and you've been able to make it concrete. And then the third stage is you're actually able to fix it. You're able to pay back that principal on that technical debt and prevent that future slowdown. One thing I want to point out is for not all technical debt can actually get to that fixable stage. There's going to be some complexity that builds up over time in a system, and you can never really reduce it to zero. But one of the goals is to push more and more of your technical debt through the stages of this life cycle and get it to that fixable stage.
So let's start with some examples where it is quite clear that something is wrong, but it's not so clear what that is. And here we see two code snippets. And in one case, it is a code quality tool, which is complaining about low code quality. And in the other case, it is a human reviewer who wrote this "what is this function doing" comment. And in case you are wondering, it was me from my own code base. So all the snippets you will see in the next slides come from a hobby project of mine. And I decided to extend it some weeks ago when, after not having touched it for more than 2 years, and surprisingly, I got some good material for this tech talk too through this. So again, from the very same project here, we see that, so we have a class which wants to draw two charts and looks a bit convoluted. So we see that there are some problems, and I definitely had no idea how to start adding a third one here. But right now, it's quite unclear what those problematic places are.
And so these are kind of some specific examples of that intangible debt, where you have that feeling that something's wrong, or you have an early sign that something's wrong, but again, you can't quite put your finger on it. And some of the other places you might start to see this is if you start to hear comments from the rest of your team, or you're saying them yourself, like this code is too hard to understand, Or you start to see something where working on a specific piece of a project just takes longer and longer than you think it should. And every time you're estimating work on that project, your estimates are way off. Again, that's a good sign that you have underlying technical debt there, and you should dive deeper into that piece of the code base. And then the other side of it is you may actually be able to work efficiently on it, but every time you're releasing it or every time you're putting it into production, you're seeing more and more bugs cropping up around the same area of the code base. Again, this is kind of a classic example of where are you having technical debt that you might not actually be addressing yet.
And this is something which comes up surprisingly often when we talk about code quality metrics and code quality score with people, that yes, these numbers are helpful. On the one hand, because it reinforces their intuition that something is wrong, I don't know what, but it feels wrong. And on the other hand, it gives them confidence to raise these issues to their team members and other stakeholders. And this leads us to the most important strategy to manage this kind of intangible debt.
Yeah, so to some extent, intangible tech debt is actually a cultural problem within a team. It's often one of those issues where if teams aren't willing to have those discussions about where do you have technical debt in your code, and is technical debt actually a problem affecting you, it actually makes it worse and worse and worse because you're never addressing the root causes here. If you start to have those experiences within your team where that frustration is just building, things are running slower, but no one's saying, why is this a case? Or people are blaming it on people being just inefficient as developers or things like that, that's pretty much a sign that you have a cultural issue where you're not actually addressing the underlying technical debt. You need to be willing to have kind of really radically transparent conversations around, where are we having these issues and why, and diving deeper into those root causes. And you need to be willing to have them coming from any member of the team, whether that's somebody who's brand new coming in for the first time, or it's a very senior engineer who's been working on the code base forever. Everyone's going to bring their own perspective of here's how I see this code base and here's where I see these issues. And having those conversations is always going to be a net positive to helping you identify these kind of intangible aspects of technical debt and being able to capture, or being able to then fix them.
So having open conversations about these issues has the advantage that now we are able to track it, and there is a bigger chance that we will see it when this information is relevant. And there are two main times when we really want to know about the existence of these issues: during coding and during planning. And some of the usual tools which we probably use more or less frequently to acknowledge these are, for example, comments, hopefully a bit more meaningful ones than the one from me, which I showed some slides ago. Then tests are also a great tool to show what is working and what isn't. And we especially like using X-fail tests to point out some missing but should be here functionality. And on the other side, it's important that not just as developers, but also other stakeholders should be aware that these issues exist and might influence our roadmap. So for that, the usual issue tracker, task management, whatever tool might be a good choice. And there are also some tech debt issue trackers which try to follow the principle, this capture it once, see it at multiple places. And one further advantage of it, that if we start to take notes about it and track it, that might actually make it easier to transition to the next phase where the depth gets a bit more specific.
Yep. So now we're at a point where we've said we have technical debt here. We've kind of made that for tangible. But the next step is actually now specifying why is it happening. How do we actually make it more concrete so we know what the actual root cause of the technical debt is on this piece of our code, and then we can think about fixing it from there. So one of the ways that especially internally we wind up trying to see where do we have some technical debt and how can we drill down into what very specific maybe function or class is causing it is looking at a series of code quality metrics. These can be things around, we have functions that are way too long. That can be a great sign that we need to go and manually refactor that and make it clearer. It can be looking at things around complexity, which certainly then can lead to all sorts of headaches and kind of debt there. And so these are a great initial sign to kind of pinpoint a specific area, pinpoint a specific issue around the length, around the complexity, around other metrics that need to then go get fixed.
So to get one step even more concrete, we can also identify some very specific antipatterns or code smells. There are quite long catalogs of them, starting with the refactoring book and then more framework-specific things. And now we will see some examples of it, again, from the very same project of mine. So this is the closer look to that class. We have already seen some slides before. And the very first anti-pattern we can spot is strong coupling. So this class is called syncing time graph, which is probably not a good name if we take into account that in the dunder init method we are calculating some kind of values, which doesn't seem to do too much with the graphs themselves. So I should definitely split it at some point. Then another anti-pattern which occurs at several places in this same code base is magic numbers. So when I took a look after the 2-year break to this code, I had absolutely no idea where this number 5 is coming from, why it occurs so often in those 3 lines, and let alone how to, should I change it if I want to extend this code or what? A related problem is not just hard-coded numbers, but hard-coded file names. And these actually point out a bigger structural problem in this project as well. So this is a relatively small project when it is neatly split into 3 different modules, which is a good thing. The bad thing is that the interface between those modules is not really clear. It works more like one module is creating an output file with a hard-coded name, and then the other one assumes that this hard-coded file name exists, which makes the communication between them not so clear. And yes, we have another structural point here. So the code you are seeing is completely fine, except that it occurs in all 3 modules. And that actually gave me some difficulty when I was trying to run that code again after a longer break. I was seriously wondering that, okay, where is the entry point? In which order should I run which steps? And how is this supposed to work? So even in such a small case, such a small project, it can lead to, and one person, it can lead to some confusion. And then the ever favorite, where again, what is this function doing? Why I myself didn't know this is probably because this add TT name is not really clear, and that is probably the most frequent anti-pattern what we see.
Yeah, and so these are just a couple examples that Reka gave of some anti-patterns that she was encountering, but there are loads out there. Here we just kind of quickly scan that project, and you can see there are a half dozen or 10 or so different anti-patterns that appeared in that quick project. But there are hundreds out there that I think we're all familiar with and all encounter. And being able to identify these anti-patterns within our code can then help us make those causes of tech debt more concrete and start to guide us down a path for how can we then think about the next step, which is actually how do we start to fix this debt.
Yes, and so here we can again start with our last example, because this is the one which is probably the most straightforward to fix, that if we don't call this function add dt, but instead we say add syncing times to line, then it becomes much clearer what it is supposed to be doing actually. And renaming is often one of those very first steps which can help in cleaning up part of such a bigger mess. And one caveat to this is that especially if the structure of the project is unclear, it might be not obvious what belongs to the public interface and what isn't. And this raises also the question, what is safe to rename, and where it might have some unintended consequences like breaking third-party code. So renaming is the step which we recommend really, but only for places where we think that it is internal and isn't part of the public interface by any documented or undocumented way. Then there is another thing, another thing which is probably in this early quick wins category. So again, in the same script, whenever we were showing pictures, it used hard-coded the empty paint program, which is making it less flexible and also way too much implementation, provides way too much implementation detail. So introducing a helper method for this is one of these first quick steps we can do. And it is especially helpful if you plan to extend the code and add even more functionality, then this suits really well as a preparatory refactoring step.
And so we might be looking at these and thinking they're small fixes or relatively straightforward fixes to kind of this broader problem of technical debt. And they might look trivial, but they're often a good first step. And we should take advantage of small fixes where we can make them to start cleaning up our code. Because first of all, they're just an easy win and they're an easy improvement, but they also tend to then help make the code clearer and help us unlock bigger, more complex changes down the line. And when we think about how do we actually prioritize which pieces of technical debt we try and actually fix, we kind of gauge things on kind of a 3-axis framework, which is how important is that section of our code base? How often are we touching it? How often is it actually being used by end users? And then we think about what is the risk to change. So Rika mentioned earlier around renaming things. If that's something where it's going to potentially be then being used by third parties and us renaming it could break things, that's probably high risk. We probably want to think about whether that's the first thing we should tackle. And then finally, it's around how easy or hard is it to actually implement these fixes. If they're really straightforward, they're really easy, it's pretty much a no-brainer. We should just go and tackle them. If they're going to be more complex fixes we actually have to make, they're going to be like larger structural changes we have to make to the code to kind of fix some of this debt, we then really only want to be doing it if it's a low risk and really high importance opportunity there.
So after seeing all this, it is a natural next thought to occur that, hey, why did we allow to happen this in the first place? How could we prevent technical debt, both in this project and perhaps also in the ones which we are just starting out? And this is basically a great point with the emphasis on preventing it but not eliminating it. And again, there is this great analogy with friction. In the book Managing Technical Debt, they compare technical debt to friction in mechanical engineering problems. That yes, friction is something we want to reduce, and the less we need to deal with, the better off we are. But we can never expect friction to be zero on planet Earth. And in a similar manner, we shouldn't expect technical debt to be zero in any kind of software project, even in such a small one, which we have seen.
And so when we think about actual strategies to prevent it, we kind of think about 3 big strategies. So the first is, and actually all 3 of them are really getting back to this kind of cultural idea that tackling technical debt is a cultural team problem. And so the first is really having consistent rules, styles, and guidelines across your entire code base and across your entire team. If we wind up in a situation where everyone on the team is kind of writing code in dramatically different ways, it's going to increase the risk of technical debt over time, and it's going to increase that buildup naturally. So coming to an agreement on how do we want everything to be structured is going to be a good first step. The second piece is actually aligning team and team culture that technical debt is something we want to reduce and prevent across the board. As we were saying earlier, if we can get to a place where everyone's comfortable having these conversations about pointing out where are the bad parts of our code base, where are these issues, why are we actually experiencing some of these slowdowns and frustrations in our code, you're going to be in a better position to then actually prevent things. And then the third is having a really robust code review process. This may seem obvious to some teams, but it's something that's really important. If you are going through and reviewing all of your team's code and kind of holding it to these standards and these rules and guidelines that you're starting out with, you're going to kind of help prevent some of the inevitable errors from happening and kind of that tech debt from starting to build up.
So to sum up, we would like to give 4 steps for technical debt and for these different stages of technical debt. So acknowledging and tracking it is probably the most important one, and especially for this first intangible art of technical debt. And we'd like to encourage you that if you notice anything which looks problematic or even just peculiar in some manner, take a note of it, and as a team have a good system in place to take a note of it and to take it into account whenever it's relevant during coding or project management.
And then the second step there is once you've acknowledged where the technical debt exists, it's trying to specify it and say, here's what the specific problems we have that are actually causing us these issues moving forward.
And then a third step is to try to reduce it, and for that to try to spot those easy wins which we can start with and which also can help us discover further steps in the process.
And then finally, once we've started to eliminate some of our existing technical debt, it's really try and put these processes in place to prevent future debt from accumulating and kind of set up that team structure so you're really trying to be conscious about it as we move forward. Thanks so much for listening to our talk today. We're going to be out at the Sorcery booth afterwards because I think we're just slightly over time. So if you have any questions, come find us there, and we're more than happy to talk about this some more.